Text, An Introduction to ASHRAE 90.1-2019, December 9, 2024. Logos, U.S. Department of Housing and Urban Development, Pacific Northwest National Laboratory, U.S. Department of Energy Office of Energy Efficiency and Renewable Energy. Energy Code Webinar Series. Implementing HUD's new minimum energy standards for home and housing trust fund projects, November 19, 2024, 2 o'clock to 3:30 p.m. EST. An Introduction to the 2021 IECC, December 3, 2024, 2 o'clock to 3:30 p.m. EST. An Introduction to ASHRAE 90.1-2019, December 9, 2024, 2 o'clock to 3:30 p.m. EST. Alternative Compliance Pathways, TBD, register for the Energy Code webinar series at www.hudexchange.info/trainings.
Awesome. Thank you, Sean. So today we have our third webinar in the Energy Code webinar series. We're going to be talking about ASHRAE 90.1-2019. Thank you for everyone joining this call. And if you want to see the webinars that we've already hosted, they'll be posted online on the Energy Code's HUD Exchange page in the coming weeks. So we started off with a session covering the impact of the HUD USDA final determination for home and housing trust fund projects, and then moved on to an introduction to the 2021 IECC. And in the new year, we're going to be hosting a final session on alternative compliance pathways, and we'll share the date for that once we have it scheduled. Move on to the next slide.
Today's presenters: Andrew Poling, Program Analyst, Office of Environment and Energy, U.S. Department of Housing and Urban Development. Paula M. Zimin, AIA, Senior Research Analyst, Pacific Northwest National Laboratory.
So I am Andrew Poling. I'm a program analyst with the U.S. Department of Housing and Urban Development. And then after I'm going to provide a little bit of background for today's session and talk a little bit about the final determination that was published last spring. And then once I'm done with that, I'm going to pass it off to Paula Zimin, who's a senior research analyst with Pacific Northwest National Laboratory. And she's going to be talking us through all of the specifics of the ASHRAE code. We can go to the next slide.
Background.
And one more.
Context.
Perfect. So starting off with a little bit of context, the Energy Independence and Security Act of 2007, or ESA, requires HUD and USDA to jointly adopt the most recently published energy standards. It does require a housing affordability and availability test to ensure that any adopted standards don't adversely impact either of those factors. So previously, HUD and USDA had required the 2009 IECC and ASHRAE 90.1-2007. However, this past year, our final determination, which was published in the Federal Register on April 26, 2024, brought HUD and USDA back into compliance with ESA by adopting the 2021 IECC and ASHRAE 90.1-2019 standards as the minimum energy standards for new construction. So this, to get to that final determination, we obviously went through the affordability and availability testing, as well as an extensive public comment period before formally adopting the standards the end of April. So this notice does only impact new construction. And then the other thing I want to note is that the updated energy code does not apply to FHA insured or USDA mortgage financing for existing housing or manufactured housing. We can go to the next slide.
Two codes specified in statute.
And so here we have the two codes that are specified in the statute for single family and low-rise multifamily. We're talking about 2021 IECC. And then for buildings, multifamily buildings with 4 or more stories, it's ASHRAE 90.1-2019. Next slide.
Anticipated benefits. On the top right, a person holds a thermal camera in front of a building. On the bottom right, a homeowner adjusts a thermostat.
So a little bit on the anticipated benefits of this update. First off, the cost savings. So more energy efficient homes reduce energy bills and costs for homeowners. The ASHRAE 90.1-2019 standard, our analysis showed that the savings annually for each unit are around $225, while over the 30-year life cycle of the building, around $6,000 in savings per unit, up to just under $200,000 across a building. We also have significant health benefits. So improved energy efficiency often translates to better indoor air quality, with homes building to these updated standards being less likely to have mold and moisture issues, which can contribute to higher rates of asthma or other respiratory problems. Um, and that also leads into the enhanced comfort. Better insulation, efficient windows, and improved HVAC systems help homeowners and renters maintain a more consistent indoor air temperature and really lead to greater comfort. And finally, and particularly with the severity and frequency of extreme weather events over the last few years, resilience, which is a key piece here. So, building to higher energy standards can enhance a home's durability against extreme weather events and actually enable greater passive survivability for a home. And with that, what passive survivability is, they're really talking about a home's ability to maintain critical life support conditions in the event of extended loss of power or water. You can go to the next slide.
Text, estimated savings of ASHRAE 90.1 2019. In a photo, trees grow near an apartment building.
So here we have the estimated savings for ASHRAE 90.1 2019. So this standard is 22.5% more efficient than the 2007 standard, HUD's previous requirement. And in aggregate, energy savings are estimated at $1.1 million per year, or up to $53 million over the 30-year life cycle. Next slide.
Text, compliance dates for multifamily homes.
And then this is the list of compliance dates just for multifamily programs. So you can see the program event that triggers compliance. And then also in the final termination column, we have the date that the compliance date take effect. So for FHA insured multifamily, and then also public housing, so capital fund and project-based vouchers. This goes into effect 12 months after the effective date or the end of May 2025. Home and Housing Trust Fund actually just went into effect the end of last month. And then for competitive grant programs, Choice Neighborhoods, Section 202 and 811, it's the next published NOFO after the effective date. And then the other thing I just want to call attention to here is the exemption for projects in persistent poverty rural areas. So based on USDA's map of persistent poverty rural areas, which you can find online, we've extended the compliance date to 24 months after the effective date or the end of May 2026.
If Home/HTF funding is layered with other HUD funds, the later program compliance data applies.
Next slide.
Alternative compliance pathways.
And then we're also looking into and going to release a list of alternative compliance pathways to meet this standard. So industry is already building to standards that meet or exceed the 2021 IECC or ASHRAE 90.1 2019. Programs such as the low-income housing tax credit, qualified allocation plans often require or incentivize high-performance building standards, and then the IRA tax credits, which are available, reference building and require building to Energy Star program requirements or certifying to Department of Energy's Zero Energy Ready Homes program. So as I mentioned, HUD and USDA will be publishing a list of high performance building standards that are accepted as alternative compliance pathways. And this may include programs such as Energy Star certified homes, Department of Energy's Zero Energy Ready Home program, as well as other high performance building standards that set or incentivize the 2021 IECC or ASHRAE 90.1 2019 as baseline standards requirements. Next slide.
Differences in state code adoption and HUD requirements. On the right, a U.S. map appears with a key labeled code efficiency category.
And then here we have a little bit on the state code adoption and how it relates to the HUD requirements. So codes are adopted at the state or local level, and states often include amendments when adopting codes. This map here is developed by the Department of Energy and shows the code efficiency category of each state adopted code and takes into account any weakening or strengthening amendments that a state might have included to the unamended standard. So with this map showing which versions of the ASHRAE 90.1 2019 standard that states have adopted, taking into account impacts of kind of weakening or strengthening amendments. We have 14 states that currently are at the 90.1 2019 version, and then also the District of Columbia. And just to kind of walk through an example here, I want to take Ohio, which has adopted the ASHRAE 90.1 2019 standard, however, has done so with some weakening amendments. As a result, this map shows it as equivalent to the 2016 standard. In that case, the state code would not be seen as an equivalent performance level to the HUD and USDA requirement. So projects need to be building to that that unamended ASHRAE 90.1 2019, or at least its equivalent performance level. Next slide.
Text, minimum energy standards resources.
And then here we have a little bit of information on some of the resources that we've put together to support the implementation of the minimum energy standards. We have a kind of screenshot here from our webpage on HUD Exchange. And this minimum energy standards page offers a variety of resources and training materials to help assist HUD grantees, participating jurisdictions, developers, and builders with information on the requirements of the updated minimum energy standards. So resources such as introductory code materials, some information on compliance tools such as CompCheck or ResTech, some state resources as well, and then additionally technical information largely brought and developed by the Department of Energy's Building Energy Codes program. We also have some information on additional funding opportunities. And then finally, you'll be able to find the recordings of the webinars as well as the links to the slide decks on that page as well.
https://www.hudexchange.info/program/minimum-energy-standards.
And we can go to the next slide.
ASHRAE 90.1 2019.
Yep, and so that is it for me. I'll pass it over to Paula to talk us through the code.
Thanks, Drew. Just gonna share my screen now.
Logo, Pacific Northwest Laboratory. Text, comparison of ASHRAE 90.1 2007 to 2019 for new construction multifamily housing. Paula Zimin, AIA, Senior Research Analyst. Logos, U.S. Department of Energy, Battelle. PNNL is operated by Battelle for the U.S. Department of Energy. In a photo, people enjoy a park near multifamily housing.
All right, couldn't everybody see that? And hear me.
Logo, Pacific Northwest National Laboratory. Text, comparison of ASHRAE 90.1 2007 to 2019 for new construction multifamily housing. Paula M. Zimin, AIA, Senior Research Analyst. Logos, U.S. Department of Energy, Battelle. PNNL is operated by Battelle for the U.S. Department of Energy. In a photo, people bike through a park near multifamily housing.
Thumbs up.
Looks good.
Awesome. Thank you, guys. Okay, thank you for having me. Today, as Drew said, I'm going to introduce some high-level changes between ASHRAE Standard 90.1 version 2007 to the 2019 version. And again, this is specifically for new construction multifamily housing. And keep going.
Text, introduction. In a photo, Paula smiles with two young boys.
A little bit about me first. I wanted to introduce myself. My name is Paula Zimin. I am a senior research analyst at the Pacific Northwest National Lab, or PNNL. I reside in the great state of New Jersey. I went to school for architecture at Virginia Tech. I am now a registered architect in New Jersey and New York, and I've been specializing in building energy performance for 17 years. I know probably too much about ASHRAE 90.1. And I am a boy mom. These are my two sons. It's a little bit of an older picture. My older son is about my height now, so that's a little scary, but they're adorable. And other than standards, I love to hang out with them.
Text, agenda.
Okay, so this is what we have in store for you today. I'll start with a background of the DOE's Building Energy Codes program, and then review what energy codes are and the HUD minimum energy standards. Then we'll dive into the ASHRAE standard itself, comparing the changes in organization, scope, compliance paths, and compliance requirements between the 2007 version and the 2019 version. And hopefully the bulk of this session is going to be that high-level review of the key technical updates of energy efficiency requirements within the system sections themselves. I've picked out and highlighted the more significant changes that would impact multifamily buildings or mixed-use buildings. There are many more changes between the two standard versions that would not typically apply to these building typologies. And there are other subtle changes as well. So big disclaimer here is that this presentation is not comprehensive. Project teams should definitely consult with their design professionals to confirm any design changes needed to comply with the new minimum efficiency standard. The intent is really just to inform you of the larger changes to expect as you move forward with compliance. Finally, at the end of this presentation, I've included some resources relative to the ASHRAE standard 90.1-2019 and energy efficiency in multifamily buildings, as well as an appendix with some additional comparisons that we won't have time to review in more detail today. So let's have some fun and dive right in.
DOE Building Energy Codes Program.
A little bit of a background of DOE's Building Energy Codes Program, which is the program I primarily support here at PNNL. It is funded by the Department of Energy, and the mission is to support building energy code development, adoption, and implementation to achieve the maximum practical cost-effective improvements in energy efficiency while providing safe, affordable, and healthy building for occupants. To achieve this mission, the Building Energy Codes Program directive is to participate in development of energy codes, establish methodologies, and issue determinations to confirm energy codes result in energy savings, promulgate standards for federal buildings, and provide technical assistance to states and jurisdictions to implement their energy codes. To learn more about the DOE Building Energy Codes Program, you can visit our website at www.energycodes.gov.
What are energy codes?
For those of you who don't work with energy codes as much as I do, you may be wondering what are energy codes and how do they relate to HUD's change in minimum energy standards. At their basic level, energy codes set requirements for minimum levels of efficiency for buildings and homes. Energy codes are adopted by states and or individual jurisdictions along with or similar to other building codes. There are two energy codes that are the predominant building energy codes in the US, and Drew had already shown them. It's ASHRAE Standard 90.1 and the IECC. Both codes are updated on a 3-year cycle.
Logos, Energy Efficient Codes Coalition, a project of IMT Institute for Market Transformation. How energy codes affect you. Energy codes govern the efficiency of the lighting, walls and systems that surround where you live and work. A space built to a more efficient energy code increases comfort and results in lower energy bills for your home and business. Below, cross-sections of an energy-efficient home and business appear.
Okay, so energy codes are a bunch of regulations on how buildings and homes use energy, but what does that really look like? How can energy codes impact you? Newer energy codes result in lower energy bills with more stringent performance requirements on various systems and equipment, such as lighting and controls, as well as properly sized mechanical equipment and well-insulated hot water systems. Newer energy codes also result in more comfortable and healthy indoor environments with increased insulation, improved air sealing to reduce drafts, and higher performance windows that allow healthy daylight, but minimize heat flow either from a glaring sun in the summertime on the outside or keeping the warmth inside in the winter.
Text, HUD Minimum Energy Standard for Multifamily 4+ Stories, Old.
So the two predominant codes, as we said, are ASHRAE Standard 90.1 for multifamily buildings 4 stories and above, and the commercial provisions of the International Energy Conservation Code.
A double-ended arrow labeled Partners points to both codes.
In content, The energy requirements of both look very similar. IECC is largely based on ASHRAE 90.1. The IECC is usually published 2 years after the ASHRAE 90.1 standard, and they're sort of partner codes. They're meant to be equivalent. So the ASHRAE standard 90.1 version 2007 is the partner code to the 2009 IECC. And the ASHRAE standard 90.1 2007 is the previous minimum energy standard for HUD for multifamily buildings 4 stories or more.
Text, HUD minimum energy standard for multifamily 4+ stories, new.
The new HUD minimum energy standard is now standard 90.1 2009 for multifamily buildings 4 stories or more. The partner energy code is 2021, and as IECC, and as Drew mentioned, HUD will accept the 2021 IECC in place of 90.1 2019 since they're comparable energy codes. Developers and contractors in states or jurisdictions whose energy code is older than the 2021 IECC or ASHRAE 90.1 2019 will need to become familiar with the differences of their local energy code, and we hope that this overview can help with those larger changes.
Energy code incremental changes.
Taking a step back, the Department of Energy's Building Energy Code program tracks the normalized net energy use of each energy code update. This chart identifies the net average energy use reduction of both residential and commercial construction based on their respective energy codes on an energy index scale of 0 to 100. 100 represents the start of energy codes back in 1975 with ASHRAE standard 90, and 0 represents a net zero energy code. The blue dots identify the normalized net energy use of the residential energy code as written in the MEC back in 1980 through the development of the IECC in the 2000s. The green dots identify the normalized energy code of the commercial energy code, or ASHRAE standard 90.1, over each version from 1975 to 2022.
A red box highlights the chart.
The previous HUD minimum energy standard for mid-rise and taller multifamily buildings was ASHRAE standard 90.1 2007. The net average energy use reduction across all commercial construction, not just multifamily, was 69.
A second red highlight appears.
And then the new HUD minimum energy standard for mid-rise and taller multifamily buildings is ASHRAE standard 90.1 2019. The net average energy use reduction across all commercial construction is approximately 47. So across all commercial construction, this is approximately a 30% reduction between the two standards.
Text, Commercial Energy Code Efficiency Category by State, updated on September 25, 2024.
Drew showed this map earlier. This is the Building Energy Code Program efficiency equivalency mapping. If a state adopts a model code with no amendments which impact energy use, the code efficiency category will reflect the adopted energy code. If a state includes weakening amendments which reduce energy efficiency, the code efficiency category will align with an older model energy code with a closer efficiency equivalence. This map reflects the efficiency equivalency of the state codes. States that are white do not have a statewide code, and equivalency has not been calculated.
White shaded states include Alaska, North Dakota, South Dakota, Wyoming, Colorado, Kansas, Missouri, and Mississippi.
Dark green states, as Drew mentioned, have adopted ASHRAE 90.1 2019 or an equivalent efficiency code.
Dark green states include Washington, Oregon, California, Montana, Utah, New Mexico, Minnesota, Illinois, Vermont, Massachusetts, New Jersey, Maryland, Delaware, and Virginia.
Lighter green states will find a few changes will need to be made in their designs to comply with ASHRAE standard 90.1 2019 requirements.
States in light green include Hawaii, Idaho, Nevada, Nebraska, Texas, Louisiana, Alabama, Georgia, Florida, Michigan, Ohio, West Virginia, Pennsylvania, New York, New Hampshire, and Maine.
States in yellow and orange will need to make more significant changes to comply with the new HUD minimum energy efficiency requirements.
Yellow states include Wisconsin and North Carolina. Orange states include Arizona, Oklahoma, Arkansas, Iowa, Indiana, Kentucky, Tennessee, and South Carolina. Text, ASHRAE 90.1-2019 Overview.
All right, now we're going to focus more in on ASHRAE Standard 90.1 2019 specifically, and changes specific to section or organization, appendices, scope application, compliance paths, and compliance requirements.
Presentation key.
I did put together this little key to help identify where the changes are. Blue text highlights slight changes that should be noted, although the general intent of the code requirements remains unchanged. Requirements in orange text are notable changes between the 2019 and 2007 standard, but the code intent changes or expands.
Relative to 2007.
And then anything in an orange box or with a star new requirement in the upper left-hand corner are all new code sections. So we can follow along in that way.
No change in section organization.
The organization of the main sections of ASHRAE 90.1 have not changed between the two versions. Sections 1 through 12.
A box highlights system sections 5 through 10.
Each section is maintained, and there's no significant changes, although I'll get into more detail about the system section changes relative to building envelope, heating, ventilation, and air conditioning, service water heating, power, lighting, and other equipment.
Organizational changes and appendices.
Although the main sections haven't changed the standard the appendices have been rearranged a little bit. Appendices have been, appendices B and D previously discussed building envelope climate criteria as well as climate data, which is often referenced, and we'll reference that information in a little bit. But starting with the 2016 standard, ASHRAE replaced these appendices and started referencing an annex, which references ASHRAE Standard 169, which is the climate standard for ASHRAE. All right. What else? Excuse me. Appendix F in the 2007 standard was updated and shifted to Appendix I in the 2019 standard, which just includes the detailed list of changes between the 2016 version and the 2019 version. Pardon me.
Paula sips from a water glass.
I'm speaking too fast. All right, and then there's two new appendices, Appendix F, which lists DOE's minimum efficiency requirements, and Appendix H, which provides...
She advances the slide, then flips back.
Oopsie, sorry. Additional guidance for verification, testing, and commissioning, which we'll talk about also in a little bit, new requirements.
Text, scope of ASHRAE 90.1.
One important thing to note before we go any further is what ASHRAE 90.1 does not cover. ASHRAE 90.1 is a commercial building standard. It covers all buildings, including residential buildings, except for residential buildings that are single family, multifamily, 3 stories or less, or manufactured housing. So when I refer to residential buildings today or multifamily buildings, I am not referring to any of these building types.
Detached single family, up to 3 stories, attached single family, up to 3 stories, multifamily, up to 3 stories, mobile/modular homes.
When I refer to residential buildings or multifamily buildings today, I'm referring to any of these building typologies. 4 stories or more multifamily, mixed-use multifamily, 4 stories or more, and the more obvious mid or high-rise multifamily buildings.
ASHRAE 90.1 2019 Compliance Summary. A flowchart appears, labeled with the text, choose one compliance path.
Okay, so for compliance with the standard, the structure hasn't really changed, but there are 2 key additions that we should highlight.
Compliance, enter at section 4.2.1. Compliance.
First, all projects must comply as prescribed at the system level. That's step 1.
Section 5.2 through 11.2.
And all projects must comply with mandatory provisions defined for each system.
Section 5.4 through 11.4.
This is the same as the 2007 standard. The first key change is that Appendix G, which is the performance rating method and is broadly used for above code programs such as utility incentive programs or Energy Star, can now be used to show performance compliance with ASHRAE 90.1. The second significant change in the compliance summary is a new requirement for verification, testing, and commissioning, which is an expanded concept from the 2007 standard, but now applies to each and every system regulated by the standard.
Section 4.2.5 appears in orange.
A little bit more about the updates to Appendix G. Appendix G is not a new appendix, and it has been used by above code programs since the early 2000s. However, Appendix G has gone through a reorganization itself since 2007, and there are now new ways to claim additional energy credit. Some examples of additional credit that can be claimed relate to optimized orientation, right sizing of HVAC equipment, optimized use of thermal mass, optimized fenestration and daylighting design, natural ventilation and other passive conditioning strategies, reduced fan power, and the optimized selection of HVAC and service water heating system types. In previous versions of ASHRAE 90.1, credit for these conditions was limited.
Text, new verification, testing, and commissioning requirements section 4.2.5.
Related to the new section requiring verification, testing, and commissioning across all system types, this is a new compliance section further detailed in each building system section.
5.9.1 through 10.9.1.
Each building system section defines specific requirements for ventilation, testing, and commissioning, and are required regardless of the compliance path chosen, such as the performance path or one of the two the prescriptive path or one of the two performance path options.
Each performance path option also lists verification, testing, and commissioning requirements, 11.2d and G1.2.1c.
The verification and testing provider must be identified in a permit application. This third party should have been involved during design to do a design review of the drawings prior to permitting.
To confirm appropriate equipment is specified and proper maintenance clearance is provided for all applicable equipment.
Finally, a verification and testing report, as well as functional performance testing results, which is related to commissioning work, must be provided to either the owner or the owner's representative.
New compliance documentation requirements section 4.2.2.3 manuals.
Finally, and related to compliance, there is also an expanded documentation requirement related to operation and maintenance manuals. In previous versions of the standard, operation and maintenance manuals were only required for HVAC systems and power systems.
Regardless of which compliance path, ASHRAE 90.1-2019 explicitly requires the following documentation: operation and maintenance, O&M, manuals for each building system regulated by the standard. The manuals should meet industry standards as identified by references specific for each section identified in Appendix E.
Now, operation and maintenance manuals are required for all other systems, including the building envelope, service water heating, lighting, and other systems regulated in Section 10. Operation and maintenance manuals are invaluable to building operations and facility managers, particularly with turnover of staff and succession. And we want to keep track of required operation and maintenance processes and a clear list of replacement details for ongoing efficient operation of the building.
System requirement updates, highlights.
All right, we are about to dive into each individual system section, sections 5 through 10. This is a list of the key changes included in this webinar, with the most significant ones in bold text. I'm going to read through them quickly to provide and then provide more detail as we go through each system.
In Section 5, the first two requirements appear in bold.
In Section 5, which is for a building envelope, there's a new requirement for a continuous air barrier as well as leakage testing, along with updates to vestibule requirements and a prescriptive R value and U value updates.
In Section 6, the first three requirements appear in bold.
In Section 6, for HVAC, there are updated ventilation design requirements and expanded requirements for energy recovery ventilation, which will impact multifamily construction. There are also new limits on vestibule heating and cooling, updates to parking garage ventilation, installation of ducts and piping, load calculation, pumps and fans and motor sizing, oh my, and general efficiency updates on individual heating and/or cooling equipment.
In Section 6, the first requirement appears in bold.
Section 7 is for service water heating. There are expanded pipe insulation requirements and updated equipment efficiencies.
In Section 8, the first and only requirement appears in bold.
Section 8 is power and has new energy monitoring and reporting requirements.
In Section 9, the first two requirements appear in bold.
Section 9 now explicitly regulates dwelling unit lighting, reduces lighting power densities for common areas, and adds lighting control requirements. And now there is a new exterior lighting power framework.
In Section 10, the first requirement appears in bold.
And finally, in Section 10, which covers all other miscellaneous equipment, they add regulations on elevator lighting and ventilation, controls for water pressure booster pumps, and electric motors. All right, let's dive in.
Text, Technical Updates Section 5, Building Envelope. To the right, a photo of a building appears. Credit, Soma Studio and Family Apartments, Tenderloin Neighborhood Development Corporation.
So we'll start with the technical updates in Section 5. So the building envelope defines building envelope performance requirements for insulation of walls, roofs, and floors, and thermal and solar performance of windows. It also defines weather protection requirements and air sealing and air leakage requirements in the envelope system. There are 3 notable changes that exist in the 2019 standard in comparison to the 2007 standard. One is related to the envelope air leakage requirements. One is related to vestibule requirements. And lastly, some updates on insulation requirements.
Text, Section 5.4 Mandatory Provisions, Section 5 Building Envelope.
Okay, so the first 2 updates exist in the mandatory provisions of Section 5.
5.4.3.1 Continuous Air Barrier, previously Building Envelope Ceiling.
A key subsection that has changed pretty significantly is the air leakage section. The previous building envelope ceiling subsection has been renamed Continuous Air Barrier. Loading dock weather seal requirements are largely the same, but there is an update to the vestibule requirements. So let's take a look at that.
Continuous Air Barrier Section 5.4.3.1. To the right, an example building section appears with red circles at joints and junctions and a continuous green line around the entire building section. Credit, https://greeninghomes.com.
First, the new continuous air barrier subsection greatly expands the brief building envelope ceiling section from 90.1-2007. In the 2007 standard, building envelope ceiling was prescriptive, specific to sealing at joints and junctions and other building envelope penetrations. The new continuous air barrier subsection specifically requires an air barrier component within each of the building envelope assemblies, as well as continuous transition at openings and intersections. Further, there must be an overlap where the air barrier material changes, and the air barrier must resist all building pressures, either from the exterior or interior. In this way, no one material can be relied upon to be the air barrier. One way a design team can design a continuous air barrier is to draw a continuous line around a building section representing the air barrier system, as shown with the green line in this building section. At each intersection of different components, such as at building overhangs, window openings, or roof transitions, the details in these locations should show what components make up the air barrier and how they will overlap to maintain continuity.
Continuous Air Barrier Design and Installation Section 5.4.3.1.2. 2 plans appear with Section Key Typical Multifamily Building on the left and Plan Key Typical Unit Plan on the right. Credit, Stephen Winter Associates Incorporated https://www.swinner.com/about-us/news/air-ceiling-guides.
The 2019 standard maintains the majority of the 2007 standard's prescriptive sealing requirements at joints and junctions. In the continuous air barrier design and installation section, The requirements are slightly modified to better integrate with the continuous air barrier requirement.
Text, E. The following areas of the continuous air barrier in the building envelope shall be wrapped, sealed, caulked, gasketed, or taped in an approved manner to minimize air leakage. 1. Joints around fenestration and door frames. 2. Junctions between walls and floors, between walls at building corners, and between walls and roofs. 3. Penetrations through the continuous air barrier in building envelope roofs, walls and floors. 4. Building assemblies used as ducts or plenums. 5. Joints, seams, connections between planes and other changes in continuous air barrier materials.
There are several available resources online to help understand multifamily whole building air sealing at the component level, as well as translating this to a continuous air barrier system. This example was prepared by an energy consulting firm, Stephen Winter Associates. They have prepared an air sealing guides for 3 different multifamily construction types: masonry, steel, and wood construction, which cover common air sealing details found in the multifamily building typology. This link and other air sealing guides will be provided in a consolidated resource page at the end of this presentation.
Whole building air leakage, section 5.4.3.1.1.
The new continuous air barrier subsection also requires testing of the system to confirm the installation achieves the intended performance. This is essentially one step in commissioning the continuous air barrier system. Testing of the continuous air barrier system is required in all climate zones. Testing is conducted with a whole building pressurization test using blower door equipment. In buildings larger than 50,000 square feet, partial building testing, such as floor by floor, is permitted. HUD also accepts compartmentalization testing in accordance with Energy Star multifamily guidelines. The design and installation of the air barrier must be inspected and tested by an independent third party.
Air leakage testing, section 5.4.3.1.1.
Air leakage testing with blower door equipment can be conducted by envelope and/or energy consultants. Look for certifications such as HERS Energy Raters or training by a nationally recognized organization such as the Air Barrier Association of America. The images on the right are examples of blower door testing equipment. The upper photo is set up in a dwelling unit. This testing is considered unit by unit or compartmentalization testing. The lower photo is a setup in the entrance to a building and is testing the air leakage of the whole building.
Section 5.4.3.3 Vestibules and revolving doors, section 5 Building envelope. Vestibules and/or revolving doors are required at building entrances. Building entrances include any doorway, set of doors, revolving door, vestibule, or other form of portal that is ordinarily used to gain access to the building or to exit from the building by its users and occupants.
All right, vestibules. The vestibule section has been updated to include revolving doors. The fundamental requirement has not changed. It's just that ASHRAE 90.1 recognizes that revolving doors achieve the same energy or equivalent energy savings as a vestibule. Vestibules and/or revolving doors should be used at all building entrances. Building entrances include any main access point ordinarily used by regular occupants or visitors to access a building. The key change for a multifamily building is that vestibules or revolving doors are now required in all climate zones, no exceptions. Building entrances can include the main entry door from a street, potentially a back entrance from a parking garage or courtyard area, and entrances from a parking garage, perhaps to an elevator lobby.
Some exceptions defined only apply to the air barrier requirements of vestibules. These are not commonly applicable to mid or high-rise multifamily buildings.
All right, we're going to go into some insulation updates in a second, but before we do that, I wanted to share this map, which is, as previously referenced, from ASHRAE Standard 169, which identifies climate zones by county. If you do not know your climate zone, look for it here. Climate zones are determined on a scale from 1 to 8, with 1 being more tropical and cooling dominated, found in Florida and Hawaii, for example, up to zone 8, which only I think exists here in Alaska. That's a heating dominated climate. In addition, climate zones are assigned a letter based on humidity. Higher humidity climates are assigned the letter A. This would include Omaha, Nebraska, or Oklahoma City, and extends east to Maine and Florida. The drier parts of the country are assigned the letter B and include eastern Washington, Oregon, and California, and extend over the Rockies and includes all of Montana, Wyoming, and Colorado. A sliver of the western states along the Pacific coast are considered marine and are assigned the letter C. Take note now of which climate zone you may be doing your work in to follow along with updates on insulation.
Section 5 Building Envelope, Section 5.5. Prescriptive Insulation Requirements. Figure 520 EN36 Window System to Opaque Wall Connection, A, Planejam An, B, Section Itsil, figure created by Keith Boswell, FAIA.
Okay, so some changes in thermal requirements for fenestration or window performance. There was a fundamental shift in categorizing windows first. Whereas in the 2007 standard, there were different performance requirements based on the material of the window frame. The 2019 standard ignores framing material, but offers a higher U factor allowance for operable windows versus fixed windows.
To the right, a table titled Residential Fenestration/Window Assembly U Factor, 0 to 40% WWR. Text, U value ranges exclude entrance door performance requirement. Lower U value reflects fixed window performance requirement, higher U value reflects operable window performance. Image, ASHRAE Energy Design Guide for Energy Multifamily.
Climate zones 1 through 3 see the greatest reduction in maximum U factor performance, with moderate decreases in maximum U factor performance from climate zones 4 through 8, within about a 1/10 reduction.
Section 5 Building Envelope, Section 5.5 Prescriptive Insulation Requirements. Tables 5.5.5.0 through 8 define maximum fenestration to gross wall area ratio as 40%. To the right, several buildings cluster in a photo.
Section 5.5.4.5 is a new section and puts limits on fenestration or window area of east and west oriented fenestration or windows. For prescriptive compliance, the east and west facades cannot have a fenestration area that exceeds 25% of the gross exterior wall area of that specific orientation. There are adjustments that can be made to this area restriction with improved solar heat gain coefficients or shading. This restriction may be the most impactful to urban infill projects, which may have little option around orientation of windows.
Text, image credit, MAP Architects.
This photo is of an urban infill building and shows an east-facing facade that exceeds 25%. To meet the new requirement, the solar heat gain coefficient will need to be reduced or shading provided to the windows to minimize heat gain from low sun angles that occur in the morning and the evening.
Section 5 Building Envelope, Section 5.5 Prescriptive Insulation Requirements. On the left, a diagram represents the junction of a roof and wall. On the right, a table titled Attic and Other R Value appears. Image, ASHRAE Energy Design Guide for Energy Multifamily.
Here is a updates to attic insulation. These are the prescriptive requirements. There have been no changes in climate zones 1 to 3. Those remain at an R38 insulation level. Climate zones 4 to 6 have increased from R38 to R49. And climate zone 7 increased from R38 to R60. And climate zone 8 increased from R49 to 60 as well.
Text, Section 5 Building Envelope, Section 5.5 Prescriptive Insulation Requirements. On the left, Figure 5.8. EN30 Roof Drain Insulation. Figure created by Keith Boswell, FAIA. On the right, a table titled Insulation Entirely Above Deck Roof R Value. Image, ASHRAE Energy Design Guide for Energy Multifamily.
Across the board for insulation entirely above the roof deck, so this will be flat or structurally sloped roofs. The 2007 standard across the board had R20 continuous insulation as the minimum insulation value. And standard 90.1-2019 increases from R25 in zones 1 to 3, R30 in zones 4 to 6, and R35 in climate zones 6, 7, and 8.
Text, Section 5 Building Envelope, Section 5.5 Prescriptive Insulation Requirements. On the left, Figure 515. EN34 Wall Masonry Attachment Classing Lateral Support. Figure created by Keith Boswell, FAIA. On the right, a table titled Wood Frame Wall R Value. Image, ASHRAE Energy Design Guide for Energy Multifamily.
For wood-framed walls, prescriptive insulation requirements increased slightly in climate zones 3, which increased standalone cavity insulation to R20, in climate zone 8, which increases continuous insulation from R15.6 to R18.8. Climate zones 3 through 7 also include 2 prescriptive compliance options. In climate zones 3 and 4, a project can be compliant either with standalone cavity insulation of R20 or a combination of insulation with R13 cavity insulation and R3.8 continuous insulation. Climate zones 5, 6, and 7 also have 2 compliance options, but both options require both cavity insulation and continuous insulation.
Text, Section 5 Building Envelope, Section 5.5 Prescriptive Insulation Requirements. On the left, a photo titled Closed Cell Spray Foam with Spray Applied Cementitious Fireproofing Layer. Credit, Building Science Corporation, https://building-science.com/documents/building-science-news-letters/BSI-124-parking-garages. On the right, a table titled Mass Floor R Value, Above Parking.
Our last highlight of insulation requirement changes are with mass floors, which are often seen in multifamily construction when there's a parking garage. Insulation requirements for mass floors have increased across the board from zones 3 through 8. In climate zone 3, required continuous insulation increased from R8.3 to R10, and in climate zone 8, required continuous insulation increased from R16.7 to R23.
Text, Technical Updates Section 6, HVAC. On the right, an HVAC system appears in a photo. Credit, multimechanical.com.
All right, onto the technical updates for HVAC systems and equipment. This section covers mechanical systems serving heating, cooling, ventilation, and refrigeration services.
Section 6, HVAC, Key Updates applicable to typical multifamily new construction.
There are several updates in this category, and due to time limitations, I'm going to highlight 4 of them. There is updated requirements in ventilation design, energy recovery ventilation, vestibule heating and cooling, and minimum system efficiencies. Some of the other notable updates that we don't have time for today relate to parking garage ventilation, insulation on ductwork and piping, load calculation and pump requirements, and efficiency requirements for fans and motors. Some information regarding these updates can be provided in an appendix when this presentation is shared later.
New mechanical ventilation requirement, Section 6, HVAC ventilation design. Requirements for multifamily 6.5.3.7. Required minimum outdoor air rate is the larger of, standard 62.1 for common areas and commercial areas in mixed-use buildings, and standard 62.2 for non-transient dwelling units. Requires vented kitchen range hood, make-up air for dryers with exhaust and mechanical outdoor air for each unit. On the right, a diagram represents a mixed-use building with a portion that requires ASHRAE 62.2 for residential buildings and a portion that requires ASHRAE 62.1 for common areas or commercial spaces. Credit, ASHRAE 62.2 2016 User Manual.
Right. So in the ASHRAE 90.1-2019 standard, section 6.5.3 is a new section. Oh, it's not a new section. It outlines provisions for air system design and control. Some parts of the section relate to fan system power and efficiency and various fan controls. A new part within this section is a ventilation design for a building. Specifically, this new section requires compliance with ASHRAE 62.1, which is ASHRAE's ventilation standard for commercial buildings. For all common area spaces or commercial spaces in a mixed-use building, ASHRAE 62.1 is the appropriate ventilation standard. However, for dwelling unit ventilation, design teams should reference standard 62.2, which defines ventilation requirements for residential or dwelling unit spaces regardless of the height of the building. As shown in this diagram from the ASHRAE 62.2 user manual, ASHRAE 62.1 should be used for any commercial spaces of a building or shared common areas such as common laundry rooms, meeting rooms, or hallways that connect, stairwells and elevators and apartments. 62.2 regulates ventilation requirements in unit-only spaces. So those areas outlined in the dashed blue line would be for 62.2.
On the diagram, a dashed blue line outlines the residential portion. Text, Ventilation Design Section 6.5.3.7.
Also, in ASHRAE 62.2, the 2019 standard has a different definition for natural ventilation than the 62.2 2007 standard. Natural ventilation, as previously defined, is no longer a realistic compliance pathway for ventilation of a dwelling unit. Mechanical ventilation is required in all dwelling units.
Outdoor air ventilation systems shall comply with one of the following. The system includes exhaust air energy recovery complying with Section 6.5.6.1. Dampers, ductwork, and controls shall be provided that allow the system to supply no more than the required minimum outdoor air rate with a single set point adjustment. Design minimum system outdoor air provided shall not exceed 135% of the required minimum outdoor air rate.
So while mechanical ventilation, while critical for occupant health, will necessarily increase energy usage. To minimize the impact of the increase in energy, this section includes additional requirements to either recover heat energy through energy recovery system, or include additional air regulation controls to maintain the set outdoor air rate, or design the system so that it does not provide excessive outdoor air. These three options are applicable to all ventilation systems, either residential or common area. So the options might also change based on each system and other requirements within the standard.
Energy Recovery Ventilation Requirements, Section 6.5.6 Energy Recovery, 6.5.6.1.1. Exhaust air energy recovery for non-transient dwelling units.
Based on the required ventilation design air, ASHRAE has also defined energy recovery requirements for non-transient dwelling units, or long-term renters or owners who, by definition, occupy a unit for more than 30 days. All dwelling units across all climate zones are required to have energy recovery ventilation, except for climate zone 3C, which is the central California coast, and units smaller than 500 square feet in climate zones 1, 2, 3A and 3B, 4C and 5C. The ERV system can be a unitary system or a centralized system. Energy recovery ventilation transfers the heat from one airstream to another. The two streams are the exhaust air from the inside of a building and the fresh outdoor ventilation air. In colder climates, the heat from warmer inside air can be transferred to colder incoming air to help temper that air. Similarly, in warmer climates, warmer outdoor ventilation air can be cooled down through heat transfer with cooler exhaust air from inside of building. This heat transfer can reduce the heating or cooling load inherent to introducing outdoor air to a dwelling unit or building.
Design Options, Energy Recovery Ventilation. On the right, a dual diagram compares unitized versus central ERV. Credit, Stephen Winter Associates Incorporated.
If a project is required to provide energy recovery ventilation, this can be achieved with a centralized system that is ducted throughout a building or from within each dwelling unit. They can have a dedicated ventilator. There are pros and cons for each option. Key factors to be considered are impacts to floor area, electricity costs and who pays for what, and maintenance costs and schedule. I've included in the resources section a link to an article prepared by an energy consulting firm, Stephen Winter Associates, discussing this comparison in more detail, which could help project teams figure out which one would be better for their project.
Text, Vestibule Heating and Cooling Controls, Section 6.4.3.9.
Another new requirement in Section 6 includes thermostat set point limitations for heating and cooling in vestibules. There is now a maximum set point of 60 degrees Fahrenheit in heating for vestibules, but that heat can only come on when it is below 45 degrees Fahrenheit outdoor air temperature. In cooling, you cannot set your thermostat in vestibules lower than 85 degrees Fahrenheit. There is an exception to the above. Heating or cooling that is provided by site recovered energy or transfer air that would otherwise be exhausted can be used for conditioning vestibules.
Equipment Sizing and Efficiencies, Section 6, HVAC. Efficiency rating based on new testing procedures, not a one-to-one comparison by value alone.
All right, the last bit to the HVAC section is across all systems, there have been updates to efficiency requirements. HVAC efficiency minimums cannot be traded off. All equipment must meet or exceed minimum efficiency requirements identified. Here are some examples of some common HVAC systems found in multifamily buildings, both unitary or systems that are within individual units, and central systems, which serve either multiple apartments or a whole building. We have a split system air conditioner and a furnace. The furnace, its AFUE requirement has increased slightly to 80%. Thermal efficiency stays the same at 80%.
She advances the slide, then flips back.
Sorry. And for the cooling efficiency, the 2007 standard had 13.0 SEER. The 2019 standard has an updated SEER 2 rating of 13.4 required. They're going to be hard to compare because there's a different testing procedure between the two, but there's generally an increase in efficiency. In a split system heat pump, there's a similar increase on the cooling side, an increase to 14.3 SEER on a split system heat pump for cooling. On heating, it looks like a reduction of efficiency, but again, the efficiency rating is based on a new testing procedure. So there should be a general increase in efficiency in the 2019 standard for heating in a heat pump. On the central system design, the boiler efficiency has remained the same between 2007 and 2019, with a caveat that very large boilers, over 1 million BTU-H, would need to achieve a 90% thermal efficiency. But that's not good. That's not very common. It would be a very large building that would have that big of a boiler. On the cooling side, for a PTAC, the efficiency ranges depend on the capacity of the PTAC. So the range in 2007 was a 9.3 ear to 11 ear, and that has increased slightly to 9.5 to 11.9 ear. On the water source heat pump side, the boiler remains the same at 80% thermal efficiency, whereas the heat pump itself that would be within a dwelling unit increases slightly on the cooling side from 11.2 to 12 ear to 12.2 to 13 ear in the 2019 standard. And then the COP, again, efficiency rating testing procedure has changed between 2007 and 2019. So we're comparing a 4.2 COP to a 3.5 IS COP.
Text, Technical Updates, Section 7, Service Water Heating. On the right, water heaters appear in a photo. Credit, DOEZERH Webinar, Efficient Hot Water Distribution in Zero Energy Ready Multifamily Buildings.
All right, moving on to Section 7, which covers service water heating systems. In multifamily buildings, this system is actually more commonly identified as the domestic hot water system, providing hot water to faucets, showers, and clothes washers. There are minimal updates in this section, really focused on pipe insulation and equipment efficiencies.
Text, Technical Updates, Section 7, Service Water Heating Summary of Changes.
Because there are less changes, I can kind of walk you through how how 90.1 changed through the years. There were no changes in this section in 2010, in the 2010 standard. In the 2017 standard, there was an introduction of the high capacity service water heating systems that I just mentioned that also exist in the heating HVAC section.
On a table, she refers to the 2013 section.
This would apply to centralized domestic hot water systems with a very large capacity of 1 million BTUH or more. Again, it's not common, but hey, might happen. In the 2016 code, there is a new requirement for installation of the first 8 feet of branch piping.
Text, connected to a pipe that is heated by recirculating hot water, heat trace, or impedance heated pipe.
We're going to get into that a little bit. On the next slide, I have a detail that we can follow. And then in 2019, there were some updates to minimum performance requirements for the efficiencies. And the efficiencies, that was really done just to align with the federal minimum standards.
SWH branch pipe insulation, Section 6, Service Water Heating, Figure 7b, Pipe Insulation Requirements, corresponding section, Service Hot Water Piping Insulation, 7.4.3. Credit, ASHRAE 90.1 2016 User Manual.
Okay, so the new insulation requirement for branch piping, it relates to recirculation systems. So this is a central system in multifamily buildings. The heater, which is most commonly a boiler, sends hot water to a storage tank, and then a recirculation loop snakes through the building to service the dwelling units. Insulation has been required from the boiler to the storage tank, as well as on the recirculation loop in the 2007 standard. What is new since the 2016 standard is that the branch piping, which is the piping that branches off of the recirculation loop piping, must also be insulated for the first 8 feet of the branch pipe. The branch piping in this diagram is located within that dashed orange box. So that's a new requirement to insulate the first 8 feet of that branch piping.
Text, Technical Updates, Section 8, Power. On the right, a diagram represents electrical distribution in a large building. Credit, arctoolbox.com.
All right. There are a handful of updates in Section 8 for power that could be applied to multifamily buildings. First, there are new performance requirements for dry type transformers. If this is interest to anybody out there, put in something in the chat and we could talk about that a little bit further. There's also a new modification to voltage drop. In the 2007 standard, feeder conductors were limited to a 2% drop and branch circuits were limited to 3%. By 2019, the standard recognized that electrical engineers could combine that limit as 5% total and no longer put limits on the individual parts of the distribution system. In this diagram on the right, we show a schematic of the electrical distribution system. The feeders are the primary distribution lines coming up from the meter. The branch circuits branch off of that primary line to each floor. So that's where the voltage drop would need to be calculated and limited. There is also a requirement for automatic receptacle controls, which will likely only apply to like a central office or business center in a multifamily complex. This requires 50% of non-essential outlets to have a central control switch to automatically turn off, either with a vacancy sensor or during non-business hours. So not as common in multifamily, but it could pop up. And finally, and most importantly, there is a new requirement for electrical energy use monitoring and recording. So this is what I will discuss next.
Text, Technical Updates, Section 8, Electrical Energy Monitoring, 8.4.3, 8.4.3.1, Monitoring.
So in a typical multifamily building, Individual electric meters are usually provided for each dwelling unit. This isn't anything new. In addition to being separately metered, common areas greater than 10,000 square feet must also separately meter major building systems, including HVAC systems, interior lighting, exterior lighting, and receptacle circuits. So those all have to be metered separately from each other.
8.4.3.2. Recording and reporting.
Also, in those common areas that are larger than 10,000 square feet, energy use must be recorded in 15-minute intervals and able to be reported in hourly, daily, monthly, and annual summaries. In a mixed-use building with commercial tenant spaces greater than 10,000 square feet, these energy use reports must also be provided to the tenants. In multifamily buildings with digital control systems, such as a building automation system, the common area energy use data must be able to be graphically displayed. The building energy use data also must be maintained for at least 36 months.
Technical updates, Section 9, Lighting. In a photo, a homeowner changes a ceiling fixture light bulb.
All right, 2 more technical sections to go. Section 9 covers interior and exterior lighting. Specific updates to this section relate to new dwelling lighting requirements, updates to lighting power densities in common areas, and expanded control requirements, and a new framework regulating exterior lighting.
Text, Interior Lighting Efficiency and Controls, Section 9, Lighting, Dwelling Units, 9.4.3.
All right, first up is interior lighting. ASHRAE 90.1 version 2019 now explicitly regulates hardwired lighting in dwelling units. At least 75% of permanently installed lighting fixtures in units must have either high efficacy lamps, which is defined as greater than 55 lumens per watt, or have a total luminaire efficacy of greater than 45 lumens per watt. In general, but not universally, LED lamps and LED fixtures will achieve the efficacy requirements here. Additional updates have been made to lighting power density allowances, or LPD, by space type of at least about a 20% reduction. Committing to LED fixtures will also help to achieve these lower lighting power densities. More significantly, there are additional control requirements in these common multifamily space types. Corridors, lobbies, and stairs require some level of bi-level control with occupancy or vacancy sensors for partial off operation. There are similar bi-level control requirements in parking garages. There may be some exceptions that are allowed based on population, such as for senior housing.
Exterior Lighting, Section 9, Lighting. A table contains columns for lighting zone, zone alias, description, base site allowance, tradable surface categories most applicable to multifamily buildings, and non-tradable surface categories most applicable to multifamily buildings. A note for zone alias reads, not an official zone name, suggested rule of thumb for multifamily but should be confirmed with local jurisdiction.
Moving on to the exterior lighting, there is a new framework of an allowance of exterior lighting allowance between the 2007 standard and the 2019 standard. The new framework identifies a base site wattage allowance connected to a lighting zone, which is from 0 to 5.
Text, new exterior lighting allowance defined by lighting zones.
I've given each zone my own personal alias here to help understand them better. Lighting zone 0 should be considered like a dark sky location. 0 light pollution allowance, definitely in national parks, state parks, there's no light allowed on the site at all. Zone 1 is for rural spaces or developed areas on parks and national or state forests and otherwise rural lands. I call Zone 2 the default zone, probably the most commonly used zone, particularly for residential construction. Zone 3 is a brighter version of Zone 2, so this could be in a downtown area and generally urban in nature. Zone 4 is sort of like zone 0 and should be very uncommon. This would be appropriate for a project, for example, located in the middle of Times Square or on the Vegas Strip. Similar to the old framework, there are tradable lighting areas such as uncovered parking, buildings, grounds, and entryways, and non-tradable surfaces, including building facades. The standard does not want to encourage excessive lighting of building facades. The last key change relative to exterior lighting is a new power reduction control requirement, so sort of like bi-level lighting for pole-mounted parking lot lighting that exceeds 78 watts per fixture and with mounting height shorter than 24 feet. All right.
Technical updates, Section 10, Other Equipment. On the right, diagrams represent traction and MRL traction elevators. Text, image, Samantha Yost, climatesafehousing.org/resilient-elevators.
On to our last system section, which is System 10. It covers miscellaneous equipment such as elevators, water pressure booster pumps, and electric motors.
Technical updates, Section 10, Other Equipment. Section 10 scope covers elevators, services water pressure booster systems and electric motors.
There are updates to each equipment category as follows. For elevators, ASHRAE 90.1-2019 now regulates controls for elevator cab lighting and ventilation systems. Both systems must de-energize when in standby mode. For water pressure booster pumps, the pumps have new control requirements to achieve the best efficiency point during operations. And finally, electric motor efficiency requirements have been updated to reference DOE efficiency standards and no longer NEMA. This mostly impacts larger central ventilation fans or pumps.
Summary.
All right, we did it. Did I lose you? Are you all still there? So in summary, ASHRAE 90.1-2019 is the new HUD minimum energy standard. Everybody got that? Check. There are 3 compliance pathways. There previously were 2. One is prescriptive and 2 performance pathways.
Section 11 and Appendix G.
Each compliance pathway also now requires operation and maintenance manuals for all of those technical system sections, as well as testing, verification, and commissioning of each building system.
Operation and maintenance manuals for each building system is defined in Sections 5.7.3.2, 6.7.3.2, 7.7.3.2, 8.7.3.2, 9.7.3.2, and 10.7.3.2. Testing, verification and commissioning of each building system, as defined in Sections 5.9, 6.9, 7.9, 8.9, 9.9, and 10.9.
And then the key updates that we reviewed today are primarily bolded, continuous air barrier requirement, as well as leakage testing, air leakage testing. The vestibules, they're now required in every building at those main entrances. There are some updates to R value requirements as well in the building envelope. For HVAC, there's now updated ventilation design requirements, requirements for energy recovery ventilation in many climate zones, in most climate zones, as well as vestibule heating and cooling limits. For surface water heating, we've got those branch insulation requirements, as well as some equipment efficiency updates. For power, for common areas greater than 10,000 square feet, we need to monitor that common area energy use by system type and be able to report out on it. In lighting, we have dwelling unit lighting is explicitly regulated with some efficacy requirements on the fixtures. Interior lighting and lighting controls have gotten more regulatory. And exterior lighting power allowance has this new structure. And finally, another equipment, elevators have to have a de-energizing ability on the lighting and ventilation system, and some updates on the water pressure booster pumps and electric motors. And again, in the appendix, just because we're running out of time, we'll have some notes on the parking garage ventilation, updated insulation for ducts and piping, some notes on load calculations, pumps, fans, and motor sizing, and equipment efficiency updates within that HVAC section.
Resources, 1 of 2. The left column contains links to all systems and multifamily specific resources, and the right column contains links to building envelope resources.
And I'll also leave you with some resources. When this presentation gets published, you'll have access to these links relative to additional resources to help you get updated on ASHRAE 90.1 2019 and the new concepts that are within it.
Text, resources, 2 of 2. The left column contains links to ventilation resources, and the right column contains links to service hot water resources.
And then that is it. I'm going to turn it back over to Catherine.
Text, Dana Bartolome.
Thanks so much. This is Dana.
Oh, Dana. Oh, great.
For Q&A. So just a reminder to participants, if you have a question, go ahead and put that in the Q&A box. We have a couple that have come in so far.
The presentation returns to the introduction slide.
And we did get an excellent presentation. So thank you again, Paula. Thank you, Drew, for that. So the first question that we have in the chat is, if California has adopted ASHRAE 90.1 2019, does it also apply to properties that are less than 4 units?
And so I can kind of jump in just to kind of reiterate the standards. And then Paula, I don't know if you want to talk a little bit more about kind of that relationship with ASHRAE and ICC that you mentioned a bit at the kind of top of your presentation, but just to reiterate. So for today's session, talking about ASHRAE 90.1 2019, that's buildings with 4 or more stories, but the 2021 IECC is the standard that you're looking at for single family or low-rise multifamily, so 3 or
and
less.
Specifically the residential provisions of the 2021 IECC would be appropriate for multifamily 3 stories and less. Yeah. And less than 4 units, it's irregardless of the number of units, it's the stories. Just want to clarify that too.
Okay, great. Thank you. And this next question, Paula, is also probably for you. Can an air curtain be provided in lieu of a vestibule, especially when there are space constraints?
Yes. Yes, air curtains can be used. I did exclude that mostly because I haven't in my experience seen air curtains commonly in multifamily, but yes, the answer is yes, it is an allowable alternative.
Great, thank you. So those are the questions that we have so far. Again, I'm going to hold it open for just a minute. If you guys have questions and you want them answered, go ahead and put them in the Q&A box. All right, I'm not seeing any additional questions come in, so I think that we can go ahead and end a little bit early. Paula, Drew, thank you guys again. Thank you everyone for attending.
Oh, Dana, we have one more question.
Oh, we do, great. Okay, the question is, when do we anticipate the next code update?
I'll just chime in really quickly. As I mentioned very early on in my presentation, the model codes are updated on a 3-year cycle. So we anticipate ASHRAE 90.1 to be updated in 2025, and the next version of IECC will be in 2027. What I can answer is from a HUD perspective of when HUD might anticipate an update.
Yep, and I guess just to answer that quickly, so from a HUD and USDA perspective, we're right now obviously focused on implementation of the current final determination. As part of the acceptable alternative compliance pathways, we would accept future versions of the IECC or ASHRAE standards if they meet or exceed the efficiency of the standards that we've adopted. So For instance, if the 2024 IECC is more efficient and Department of Energy is in the process of issuing that determination, we would accept it as an alternative compliance pathway. And Paula, correct me if I'm wrong here, but I believe the analysis has already been done on the ASHRAE 90.1-2022 standard.
Yes.
So that
Yep.
would already be something we would see as meeting or actually exceeding the baseline of set by the 2019 standard. So that would be acceptable.
Right.
Thank you. And I do see one question also in the chat. In a high-rise building, where are there requirements for where the mechanicals need to be located? Do they need to be in the basement, or should they be elevated above flood levels? Anything in the code on that?
Not in the energy codes and not in the minimum energy standards. I would look to zoning requirements, and I'm not familiar enough with HUD or USDA to know if there's guidelines there, that you guys have guidelines. Certainly from a resiliency perspective, keeping mechanical equipment up, away from a floodplain, et cetera, is best practice. But I don't know if HUD has a specific requirement.
Yeah, so we do have our kind of separate FFRMS rule that dictates the elevation requirements. I'll say that's not an issue that is one I work on regularly, so I would defer to the FFRMS resources that my colleagues have put together.
All right, a couple more too. Thanks, everyone. And as a reminder, keep them coming. We have a little bit of time. So if you have questions and want them answered, we are happy to do that live. So next question is just about compliance. So how does someone confirm compliance to these standards when they're working on a HUD or USDA assisted project?
So for compliance, we've largely, we haven't changed the compliance requirements from the previous energy code requirements for HUD and USDA to the current final determination. Largely, it's going to be a kind of self-certification form from builders, developers, though there are some specific programs that have their own requirements as well. The Home and Housing Trust Fund, which you can see a little bit more detail on their specific compliance requirements, have some kind of programmatic requirements beyond what we're kind of generally asking for with this update. So I'd suggest looking at that webinar and slide deck once it's posted in the coming weeks for more information there.
And one final question, can we review the compliance deadlines for these programs? I know you mentioned it earlier. Maybe we can just go back to that slide for a second. And then the second part of the question is just, if adopted by HUD, will this affect 221D4 programs?
Andrew returns to the compliance dates for multifamily program slide.
Yeah, so here we have the compliance dates with which it goes into effect. So we have implemented this with a kind of flexible implementation plan depending on the program. Home and Housing Trust Fund, it went into effect at the end of November, so already a requirement for those programs. And then for FHA insured multifamily and also our public housing programs, capital fund, project-based vouchers, it goes into effect. So it is a year after the effective date, or May 28th, 2025. And then we also have our competitive grants, Choice Neighborhood, Section 202 and Section 811. And there it's going to be for the next published NOFO after the effective date. And then, as I mentioned before, the one exemption we have is for projects in persistent poverty rural areas. So across all impacted programs, projects that fall into those regions of the country have a implementation date that's actually 24 months after the effective date. So that's not going to go into effect there until May 28th, 2026. And you can find those areas on USDA's website on their persistent poverty rural areas map. And then I don't believe 221 is a covered program.
Okay, great. And how about project-based vouchers? Is that covered by the HUD minimum energy standards?
Yes, so that's one of the programs covered that impacts public housing. So we've got capital fund and then also project-based vouchers. And as mentioned, that's going to be a compliance date of May 28th, 2025. And so we are working with all of the program offices to make sure we issue kind of program-specific guidance where necessary.
Great, thank you. Okay, I'm not seeing any additional questions come in. So I will thank our panelists again. Thank you everyone for joining this afternoon. The slides and recording to this webinar will be available on the HUD Exchange Minimum Energy Standards webpage and trainings page shortly. So thanks everyone.